Hello, 8th grade. Here is your Module 4 review. All right, question 1. Oscar has a certain amount of money. If he spends $12, then he has 1/5 of the original amount left. How much did Oscar have originally? So I do apologize. I did this one incorrectly in class. So I'm just going to go through how it actually should be. So we're trying to figure out how much Oscar had originally. He spent $12, so he has 1/5 of the money that he has left is 1/5 of the total amount. So what we're going to do is we're going to do x minus 12. So we have the amount of money that he started with minus 12 is equal to 1/5 x. So 1/5 of the money that's left so if we take the amount of money that he had and subtract 12, we have 1/5 of that left. So now we can go ahead and solve that. So what we're going to do is we are going to add 12 to both sides because I need to have all of my variables on one side and my values on one side, and it's easier to have your variables on the left and your values on the right. So this then becomes x. So the negative 12 and positive 12, they cancel out. Those go away. So I have x equals 1/5 x plus 12. Okay. So now we're going to move this over here. So we're going to subtract 1/5 x from both sides. Here we have an invisible 1. So 1 minus 1/5 is 4/5. So I have 4/5 x equals 12. Now I need to figure out what that x is by itself. So here I have 4/5 times x. In order to undo that, I need to divide, but we can't divide fractions. So I'm going to multiply both sides times 5/4, which is the reciprocal. So this leaves me with x, because 4/5 and 5/4, I get 1. Then I have 12 times 5 is 60, divided by 4. So x equals 15. So Oscar had $15 to start. Okay. B we did correctly, so I do again apologize for A. I read that one incorrectly. But I will still do B for those of you who maybe missed it. All right, so 3 consecutive integers have the sum of 234. What are the 3 integers? So essentially what you're doing is you're doing a number plus a number plus a number equals 234. We don't know what that number is, so we're going to call it x. Then we have consecutive integers, means we have one following the other. And in order to do that, I need to add 1 to this to get to the second number. And then to get the next one, I'd be adding 1 here, but I'm adding 2 to that one. So I have x plus 1 plus x plus 2 equals 234. So now we need to simplify that. So I have 1, 2, 3 x's, and then I have 1 plus 2, which is 3, equals 234. Now I can go ahead and solve this. So I'm going to subtract 3 from both sides. So I have 3x equals 231. And now I need to divide both sides by 3. So I have 3x equals 231. And I need to divide by 3. So if I do 231 divided by 3, this is 7. 21, 21, 7. X equals 77. So then to find the next ones, 77 plus 1 is 78. And 77 plus 2 is 79. So the 3 integers are 77, 78, and 79. All right. C. Gil is reading a book that has 276 pages. He already read some of the book last week. He plans to read 20 pages tomorrow. By then, he will be 2/3 of the way through the book. How many pages did Gil read last week? So we know that he read 20 pages. The book is 276 total. So if we're reading, so he read some value plus 20, and that equals 2/3 of our total book. So we have x plus 20 equals 2/3 times 276, which is our total. If we simplify that, we get 184. So now we can go ahead and continue to solve. So x plus 20 equals 184. If I subtract 20, because I'm adding here, so in order to undo that, I'm subtracting. So x equals 164. He read 164 pages last week. Okay? All right. So as you remember, we did not do number 2, but based on number 1, I felt confident that you guys could do these, but I will still go over them. All right, so we're solving for x, so we need to get x by itself. So I have a negative 15 equals 8x plus 1. So my variable is on the right, so I'm going to move all my numbers to the left. So I'm going to subtract 1 from both sides. A negative 15 minus 1 is a negative 16. The 8x just comes along for the ride. Now I have a number on one side, a variable on the other, but I still have a number, a coefficient in front of that x. So I'm going to divide because I'm multiplying. So in order to get that x by itself, I need to undo everything that's happening. Those go away. So negative 16 over 8 is a negative 2. So my x equals negative 2. All right, here we have 7 times the quantity 2x plus 5 equals 4x minus 9 minus x. So we need to simplify this a little bit. The 7 needs to get distributed inside. 7 times 2 is 14. 7 times 5 is 35. Then I have a 4x minus 9 and a minus x. These two terms can be simplified. 4x minus 1x is 3x minus 9. So now I need to start rearranging where my pieces go. So this 3x is smaller than 14x, so it's going to be easier to move this over, and then you're not going to have negatives. So I'm going to subtract 3x from both sides. So 14 minus 3 is 11. The 35 comes down because I didn't do anything with it. And the negative 9 comes down because I didn't do anything with that either. Now I'm going to subtract 35 from both sides. So 11x comes down. I didn't do anything with that. This becomes a negative 44. And now I'm multiplying here, so I need to divide. X equals a negative 4. All right, Parker paid $4.50 for 3 pounds of gummy bears. Assuming that each pound of gummy bears costs the same amount, complete the table of values representing the cost of the candy in pounds. So we need to find the unit price for each. So we have $4.50 for 3 pounds. So in order to find the unit price, you have to divide. So I have 4 divided by 3, which simplifies to 150. So it's $1.50 per pound. So then we're going to use that information to fill in our chart. So for 1 pound, it's $1.50. For 2, it's $3. 3 is already filled in for you. 4 is $6. 5 is $7.50. 6 is $9. 7 is $10.50. 8 is $12. And 9 is $13.50. Okay, so now we have ordered pairs for everything. So our x's are on top, our y's are on the bottom. Our x's are down here, our y's are here. So it's telling you exactly what you're doing. So candy in pounds goes on the bottom by the x. And then our y here is cost in dollars. So now we're going to use each of these columns, and those are going to be our points. So our first one is 1 and 150, so I'm going to go over to 1 and up to about 1.5. Our next one is $2 and $3, so I'm going to go over to 2, up to 3, and make my point. The next one is 3 and 450, so I'm going to go over to 3, up to 4.5. That one goes there. The next one is 4 and 6. I'm going to go over to 4, up to 6. The next one is 5 and 750. 5, 750. Then we have 6 and 9. 7 and 1050. Up there. 8 and 12. A lot of candy that these people are buying. And 9 and 1350. All right. Then, all right, I'm gonna put you down for 1 moment. Let's do it this way. All right, so hopefully y'all can see this. So I'm just using a ruler to connect the line. So this is what your graph needs to look like. So here are my points and my line is connected. All right, on the same day, Parker's friend Peggy was charged $5 for 1.5 pounds of gummy bears. Explain in terms of the graph if she was charged the correct amount. So I need to come back over and I'm going to find 1.5 pounds and $5. So if I come over and look for 1.5 pounds, which is right about here, and I go up to see where the graph hits, that looks to be about 3 1/4. So she was charged too much. Okay, and if we come back and look at $5, that comes out to be about maybe 3 1/3 pounds. And we don't need to have exact, we're just using it to estimate. All right, number 4, use the graph to answer the following questions. Okay, so use any pair of points to calculate the slope of the line. So you need to have y2 minus y1 over x2 minus x1. Our ordered pairs are always going to be in the form xy. So all of these are going to be in that form. So the x, y, x, y, x, y, x, y, x, y, x, y. So you're going to choose any 2 of these. The ones that were chosen in class, I believe, were 0 and 6. And 4 and 0. So this is my x1, y1. This is my x2, y2. Simply because this is my first ordered pair, that's my second ordered pair. This is the first x, that's the second x. This is the first y, that's the second y. Simply because that's how it goes from left to right. So now we are going to replace these values into this equation. So I have y2 minus y1 over x2 minus x1. My y2 is 0. My y1 is 6. My x2 is 4. My x1 is 0. Now that I've replaced all of this information into this equation, now I can simplify. 0 minus 6 is a negative 6. 4 minus 0 is 4. This simplifies to a negative 3/2. So my slope using these points is a negative 3/2. So now it says use a different pair of points to calculate the slope of the line. So the points I believe we used were a 1, 4.5, and 3, 1.5. So we'll use those same points. So I have 1, 4.5, and 3, 1.5. Again, this is my first order pair working left to right. So this is my x1, my y1, x2, y2. I'm going to use that same formula. So my y2 is 1.5 minus my y1, which is 4.5. My x2 is 3. My x1 is 1. 1.5 minus 4.5 is a negative 3. 3 minus 1 is 2. So I have a negative 3/2 again. So C then says, are the slopes the same or different? Explain your answer. They are the same. Because you have a line. The slope is the same. All right, number 5. Jeremy rides his bike at a rate of 12 miles per hour. Below is a table that represents the number of hours and miles that his friend Kevin rides. Assume both bikers ride at a constant rate. So we know that Jeremy's rate is 12 miles per hour. We need to figure out what Kevin is. So what we need to do is we need to figure out the unit rate, and we can use any of these. So I'm going to do 23 divided by 2. I'm going to use this one. So this is a 1, 2, 0, 1, 2. So Kevin's is 11.5 miles per hour. Okay, so which biker has the greater speed? Explain your answer. So I know this is one that a lot of people got confused on, because in some examples, in some problems, the higher value was the answer, and some, the lower value is the answer. So we need to look at it in terms of the problem. So we're looking at greater, which one has a greater speed? So speed, the faster we go, the larger the number, the faster we go. So in this case, Jeremy has the larger speed because he's got a greater slope. Okay? All right, so now we have write an equation for a third biker, Laura, who rides twice as fast as Kevin. Use Y to represent the number of miles Lauren travels in X hours. So we're trying to figure out how fast she is. So it's telling us to write an equation. So if it's saying twice as fast, it means that she's going twice the distance in the same amount of time. So in the same time it takes Kevin to do 11.5 miles, Lauren is doing twice that much. So if we do, all right, so Y is going to equal two times Kevin, or in this case, we know that it's 11.5. So 2 times 11.5 x, or Y equals 23x. So now we are going to be graphing all three. Let me grab one more color. All right, so I'm going to do, let's do Jeremy in blue. I'm going to do Kevin in purple and Lauren in red. So for Jeremy, we already have some data. So at 1.5, he is at 17.25. So I'm going to, no, let's not do that one. All right, so we have, everyone's starting at 0. So he's at 2 and 23, which is right about there. 4 and 46, which is right about there. And then again, I'm going to connect that. Then for Jeremy, we know that his slope is 11.5. So we're going to start down here again. And for every one he's going, every hour he's going 11.5. So I'm going to, and that one's going to be just below. And then at 2, he's at, oh, sorry, hold on. This is, no, hold on. What did I do? This is Kevin. Sorry, switched them. Okay. All right, so then, sorry, Jeremy is 12, so we're going to do over 2, 24, no, wrong color. Sorry, guys. That's going to be at 24. 4 is 48, so it's just going to be slightly higher. Okay. And then last we're going to do Lauren. So at 1 mile, she's at 23. 2 miles, she's at 46. And then again, 0. Sorry, that's not as nice as it should look. So if you notice, these two are roughly the same. They're very similar. This purple one is just slightly above the blue one, and then the red one is way over. So hers is, she's writing much more quickly. All right, so what is the slope of Lauren's graph? So the slope is 23. What does the value mean? That is her speed. All right, the cost of 5 protractors is $14.95 at store A. The graph below compares the cost of protractors at store A with the cost of store B. So if you notice, I don't have any data here. So, but I do have information here. So I'm going to take $14.95 and I'm going to divide it by 5. So this is 2. So one protractor at store A is $2.99. So if I kind of add these tick marks, so this is 1, so this would be $3 roughly. So if I come across to here, this could really be any amount. So maybe that looks like 1 to you, or 2, or maybe $1.50. So you can really do anything as long as it's less than 3. So this, I'm going to say it's $1 at store B. Because it okay. All right. All right, number 7. Given the equation 3x plus 9y equals a negative 8, write a second linear equation to create a system that has exactly one solution. Okay, so we have to look to see we have exactly one solution, has no solutions, or has infinitely no solutions. So has no solution means it has the same slope. This means it's the same equation essentially. And this one means that it's different slopes. So your answers here could vary, but first we need to put it into the equation y equals mx plus b. So I need to change this so that I know exactly what my slope is. So I have 3x plus 9y equals a negative 8. So I need to move my 3x over because I need that x to be on the right side. So I have 9y equals a negative 3x minus 8. Now I need to divide both sides by 9. So y equals negative 3 9ths x minus 8 over 9. And then this simplifies to y equals a negative 1/3 x minus 8 9ths. So now, if I'm doing one that has exactly one solution, it can be anything as long as my slope is not a negative 1/3 x. So you could have y equals 7x minus 4, y equals 2/5 x plus 17. You really can have anything except a slope of negative 1/3. Now this one that has no solution, I need to have the same slope but a different y-intercept. So this one, you need to have y equals a negative 1/3 x plus or minus some value. Hello. So you can have y equals a negative 1/3 x plus 7, y equals a negative 1/3 x minus 14. Anything goes. Then for C, you need to have roughly this same equation, but in a different format. So I can have, let's see, y equals negative 26x minus 16 over 18. That would be an example. So this simplifies to that. It's the same. All right. D then, interpret the meaning of the solution if it exists in the context of the following system of equations. So you need to do the same thing here that we did for A, B, and C and compare it. So first I have a negative 5x plus 2y equals 10, and I need to put it in the same y equals mx plus b. So I'm going to add 5x to both sides. So I have 2y equals 5x plus 10, and I need to divide everything by 2. So y equals 5/2 x plus 5, because 10 divided by 2 is 5. Then I'm going to do the same thing with that second one. I have 10x minus 4y equals a negative 20. And if you look at these, I do have a common factor of 2. Here I have a negative and a positive and a negative, a positive and a negative. So it's entirely possible that I'm going to have the same equation, but I just need to verify. All right, so I'm going to do a minus 10x minus 10x. So I have a negative 4y equals a negative 10x minus 20. Now I need to divide everything by negative 4. So I have y equals a negative 10x over negative 4 minus 20 over negative 4. So this ends up being y equals, negative 10 divided by negative 4 gives me a positive 5/2 x, and then a negative 20 divided by a negative 4 gives me a positive 5. So these are the same. Therefore, they have infinitely many solutions. Excuse me. All right. Question 8. Students sold 275 tickets at a fundraiser at school. Some tickets are for children and cost $3, while the rest were adult tickets that cost $5. If the total value of the tickets sold was $1,025, how many of each type of ticket was sold? So what we need to do is, actually, I'm going to have you skip this one because we did not go over that. But I will be happy to, here, I'll just show you really quick. So what you would do essentially is you do x plus y equals 275, and then 3x plus 5y. So you have kids tickets plus adult tickets is 275, and then $3 per ticket plus $5 per ticket is $10.25. And then you would solve by substitution. Actually, yeah, we're going to do this one because you learned that. So in order to solve for substitution, I need to multiply one of these by some value to get them to be the same. So I'm going to multiply the top one by negative 3. So that's going to give me a negative 3x minus 3y equals, I'll just do it here, 15, 22, 6, 8. It's going to be 825, and that's a negative. And then I have 3x plus 5y equals 1025. So when I add those together, this negative 3 and positive 3 go away, so that's 0. a negative 3y and a positive 5y gives me 2y. And then this is going to give me 200. So if I take my 2y equals 200 and divide by 2, y equals 100. So there were 100 adult tickets. And then you can put this value back into the equation. So if I have x plus 100 equals 275, I subtract 100 from both sides, x equals 175. So we had 175 child tickets. All right. Answer the following, showing all of your work. All right, so determine the equation of the line connecting the points 0, 1 and 2, 3. So for this one, we have to first find the slope. So we're going to do y2 minus y1 over x2 minus x1. So this is x1, y1, x2, y2. So I'm going to take these values and put them in here. So I have 3 minus 1 over 2 minus 0. 3 minus 1 is 2. 2 minus 0 is 2. That simplifies to 1. So then I'm going to put it into the equation y equals mx plus b. So this is my slope. And then this right here is my y-intercept. This isn't always going to happen, but this happened to work out this way. So my equation then ends up being y equals m, which is my slope, and my y-intercept. So I have 1x plus 1. So that is the equation in that part. All right, B, will the line described be the equation in part A, intersect the line passing through the points, explain why or why not? So essentially what you're doing is you are finding if this has a different slope. So you're going to do the same thing. So this is x1, y1, x2, y2. So I'm going to do y2 minus y1 over x2 minus x1. So y2 is 3 minus 4 over negative 3 minus a negative 2. So 3 minus 4 is a negative 1. 3 minus a negative 2. So a negative 3, essentially plus 2 is a negative 1. Simplifies to 1. So they have the same slope. So they will not intersect. All right, let's look at 10 here. Okay. Line L1 and line L2 are shown on the graph below. Use the graph to answer the parts A through F. So we want to figure out what is the y-intercept of L1. So L1 is here. It goes through 4. So it is at 0, 4. The y-intercept of line 2 is here, goes through 2. So it is 0, 2. And then we are going to write a system of linear equations to represent lines L1 and L2. So if we're writing an equation, it's going to be in the y equals mx plus b, where again this is our slope, and this is our y-intercept. So we already have our y-intercepts, now we just need to find our slope. So this one is going down and to the right, so it's negative. So if I go down 1, 2, and over 1, 2, 3, 4, or here, there's a better one. Go down 1 and over 2. The slope of this one is negative 2. So L1 is going to be y equals a -2, that's my slope, x plus 4. L2 then, I'm going to do the same thing. So here, this one's going up and to the right, this one's positive. This one, if I go over 1 and up 1, so my slope is just 1. So y equals 1x plus 2 is my line. Use the graph to estimate the solution to the system. So here, we don't have a really nice place that intersects. So this looks to be about, I would say 1 1/3, 1.3, and then over comes to be about the same thing, 3.3. So that, your answers do not have to be that because it's saying estimate. If you have 1.5, 3.5, that's fine. I would roughly take between 1.2 to 1.5, and let's see, 3.2 to 3.5. I would take a range of that. So that is the last question. Reach out if you have any more, and go look some more.